Welcome back. This is 3.5 linear inequalities in two variables. Our objectives are graph a linear inequality in two variables, use mathematical models involving linear inequalities, and graph a system of linear inequalities. So linear inequalities in two variables and their solutions. If we change the symbol equal in the equation, ax plus by equals c, to greater than, less than, greater than equal to, or less than equal to, we attain a linear inequality. And then these are examples of linear inequalities in two variables, so y and x. A solution of an inequality in two variables is an ordered pair of real numbers such that when the x coordinate is substituted for the x and the y coordinate is substituted for the y in the inequality, we attain a true statement. So these are your steps to solving. If you want to go ahead and read through all of those, you can. Otherwise, I'll kind of be explaining as we go through and do examples. All right, so it says graphing a linear inequality in two variables. So what you need to do is get the y on one side. So we're going to minus 3x. Oh, it's still on my highlighter. So minus 3x. So we have negative 5y is greater than equal to 15 minus 3x. Then we divide by negative 5. So we have y. And then it changes the inequality because we divided by that negative. So less than equal to 15 divided by negative 5 is negative 3. Negative 3 divided by negative 5 is going to be a positive 3/5, and then x. Then remember we want to end that like y equals mx plus b, so y less than or equal to 3/5x because that's our slope minus our intercept. So you still treat it as like that linear function. So it'd be 0, negative 3. And then we're going to be up 3/5. So 1, 2, 3, 3, 4, 5. Up 3, 1, 2, 3. And then down 3/5, down 3/5. And then it's an equal to, so it's going to be a solid line. So I'm going to make my pencil a little bit bigger so you know that that is a solid line here. All right, and then it says less than or equal to. So that means we're going to shade, and I'm going to use green. So we're going to shade in everything below the line. Okay, so that fills in. On your assignment, it has a shading tool. It's like a bucket. It's like a paint bucket. So don't worry about like actually having to color all of it in. It'll be like a bucket tool that you'll use. All right. Then the next one. So this one is already set for y and x. So remember this is just our slope. And then we don't have an x-intercept y-intercept. So remember, if you don't have one, it's 0, 0. So then we're going to go down 2/3. So down 2/3, down 2/3, and then up 2/3. All right, and then this one, it doesn't have an equal to line, so I'm going to make my thing bigger so you can see that it has to be a dotted line. And then you'll have the option on your assignment to select a solid or a dotted line when you're graphing these. All right, then we want to And so it's greater than, so that means it's going to be above the line. So that's going to be everything above here. You can also test points above your line. So let's say above our line, so that's 1, 1. So we would have 1 is greater than negative 2/3 times 1. So 1 is greater than negative 2/3. So since that's true, that means that that section is true for the inequality. All right. So linear inequalities without test points, so you can't put in numbers like if it's a horizontal or vertical line. Just know that greater than is to the right and less than is to the left. And then for the y lines, above, so is up. So positive is up and then negative is down. So less than would be down. So greater than, less than, greater, and then less than. Okay, so just remember those for those type of equations. All right, so now we want to try that with these. So let's see if I can change my pen here. I don't know why it's doing that. Okay, so it says y is less than negative 3. So that means at negative 3, it's going to be a solid line because it has that equal to. And then less than, remember, is below here. So that means we want it below the line. All right, next one. So we have y is greater than 2. So it doesn't have an equal to line, so that means it's a dashed line at 2. And then greater than is pointing to the right. So that means it's going to be that right-handed section. I don't know. Okay, my computer wigged out for a second. So hopefully you got that when it's greater than on an x by itself, it's to the right. All right, modeling. So just like the same as we've been modeling before, and just now we want to look at where those graphs will overlap. So this one says, the latest guidelines which apply to both men and women give healthy weight ranges rather than specific weights for your height. The figure in the next slide shows the healthy weight region for various heights for people between the ages of 19 and 34 inclusive. If X represents height in inches and Y represents weight in pounds, the healthy weight region can be modeled by the following system of linear inequalities. So those two equations. So then it says, show that point A, 170, is a solution of the system of inequalities that describes a healthy weight. So when we graph this, so you can actually do this in Desmos as the whole thing. So let's go ahead and, so we're going to clear out stuff we had from the last lesson. All right, and then we're going to start with that 4.9x minus y, and then it actually has that greater than equal to, let's see, equal to, oh, I don't know why I did that. And then 165. And then we have 3.7 x minus y greater than, or no, less than equal to, I don't know why it chose that one above, less than equal to 125. All right, so we need to adjust our graph here. So notice on your notes, I put, so this is 240, and then this is, like, so in Desmos, we can change that. Let's hope we can do that a little bit easier here. So 240, and then 84 for the x. And it didn't do what I wanted it to do. So I might have to zoom out. There we go, that's better. All right. So they cross at 33 and like negative 1.5. Oh, I guess it, so from 60 to 78, it only wants those numbers. So let's zoom in over here. So 60, there we go. So at 60, you're at 97. So that's going to be right. And then 60 on this line. It's 129. So up here. And then let's find our other points. So at 86, we're at like 194. And then this one, for 256. Oh, that's above our window here. Let's do 84. Or 80, I guess. So 227. Just so we can have the two lines here. Oh. So they'll just continue to go off here and up there. Okay, so we want this shaded region in between because that's where they overlap. And then we want to find if 70, 170 is in that range. So 70 and 170. So it should be, so let's look on Desmos, we might get a better idea. So it looks like it because at 70, we're at 178. So that should be in our system. So it should be right here. So 70, 170. You can also put that in your system of equations here. So 4.970 minus 170. So 4.9 times 70 minus 170. So we're at 173. Greater than or equal to 165. So that's true because it's greater than. So then you do 3.7 times 70 minus 170. And we want it less than 125. And we get 89. 89 is less than or equal to 125. So that checks out. All right, graphing systems of linear inequalities. So it just means that the point that you're finding has to be within both sets, or the shaded region overlaps each other. Okay, so x minus y is less than 1. So we're going to subtract x. So negative y less than negative x. Then divide by negative 1. So it's going to change your inequality and then change your signs. So positive x, negative 1. Excuse me. So at negative 1 is our intercept, and then we're up 1 over 1 because we don't have a slope here. So up 1 over 1, up 1 over 1, down 1 over 1, down 1 over 1. And then it's going to be a dotted line because it's not an equal to equation. All right, then the next one, so minus 2x. So we have 3y greater than equal to negative 2x plus 12. Then divide by 3. So y is greater than or equal to negative 2/3 x plus 4. So up 4. So 1, 2, 3, 4. And then we're going to be down 2 over 3. Down 2 over 3. Up 2 over 3. And then this is going to be a solid line. Oh. All right, so we want to see where they overlap. So we have greater than our solid line. And then, what made me to blue? And then this one is also greater than. So that means they overlap in this section. I don't think the blue is a good color. Let's see. Let's maybe choose pink. There we go. Now you can see that it overlaps. So seeing this darker section, that's your solution. So they overlap in that triangle section there. So that is your solution. And then they cross at 3, 2. So at 3, 2, that's an open circle, and it's not a solution to the set. So be very careful. It has to be above those lines because you have that dotted line where it's not equal to. So be careful when you're looking for solutions that they fall above those restrictions. All right. And that is it for 3.5. So if you have any questions, please let me know. Otherwise, work on your assignment.